All right. So last lecture we talked about the different types of structural coverage. We began with the weakest one, which is node coverage, which is subsumed by edge coverage. And edge coverage says we need to have all the edges covered. And then all the edges covered, including graphs that doesn't have any edges in it. So if it's just a node, so this way the edge coverage fully subsumes the node coverage. And then next level up would be the two edge coverage. And we're looking at this example over here. Okay, we saw that edge pair coverage, the number of edges to cover is higher because they're coming in pairs. And so the number of test cases that I created for edge coverage is no longer sufficient, and I needed to create an extra test case to cover edge pair coverage. And basically, the idea that you'll actually see, you'll notice, is that there's usually certain paths, like say the 0, 2, 3, that we didn't actually have in the edge coverage, which then is exposed by looking at things from 2-pair, 2-edge coverage, and then 3-pair coverage, and 4-pair, and the higher you go in the number of edges, and this is the way it's going to be until you basically reach the maximum number of edges in a graph. Okay, and this is what we were talking about in the last lecture, and we said, well, since this is the case, then well, let's just go for the maximum. And then we talked about complete path coverage, and complete path coverage is obviously will be the best, will be the most thorough, but we will be facing a problem in case that graph that we have does have a loop inside of it, because now the number of paths that exist is infinite. Okay, so if I have a loop between nodes 1 and 2, I can just go, there's one path saying 1, 2, and then 1, 2, 1, 1, 2, 1, 2, 1, 2, 1, 2, 1, and so on and so forth. It just can go infinite. Okay, and I can't have that. And this is where prime path coverage comes into play. But before I talk about prime path coverage, okay, when we were looking at things like this slide over here, and we said like every time I go one level up in the coverage, I'm expecting that the higher level coverage would expose a bug that the lower level coverage won't. Okay, this is not necessarily true. Okay, naturally, or chances are, yes, the higher the level of coverage, the better, but it's not necessarily the case. It's almost like the case of covering a patch of field 3 times to look for a ring that has fallen, i.e. a bug, but yet with the 3 times out of luck, you never found it. Somebody else would go through that patch 1 time and then they would find it. Okay, now I've alluded to this point, I think, multiple times, and what I want to do is I want to now stop for a second, and I want to like explore this topic with you. Okay, so here I am. This is a different course. Let me just erase this. Okay, so here I am. We got this situation. All right. 1 going to a 2.
Doctor, you can't see the whiteboard.
Oh yes, sorry. My common mistake. Thank you, Abdurrahman. Okay, we got 1 going to a 2, and then the 2 going to a 1, and then this is it. This is the final node. What would be the criteria for node coverage? What would be the test requirements?
1, 2.
1 and 2. Type edge coverage. What is the test requirement?
1, 2, 2, 1.
1, 2, and then 2, 1. Okay, so edge coverage always subsumes. So this is node coverage. It's always subsumed by edge coverage, which is then always subsumed by 2 pair, and then and so on and so forth. Okay, fine. Give me a test case that I can complete the test requirements for the node coverage. That's simple. Just go 1, 2. صح? Okay. But for edge coverage, does 1, 2, is it enough?
1, 2, 1, 2.
Okay, so in other words, it's actually not enough. Let me just put this over here. So we got 1, 2, 1, 2. In other words, we're actually going in and we're looping in order to cover that second edge that's going from 2 to 1, which was missed in node coverage. Okay, so we look at it and say, wallahi, you know, if I'm doing this for edge coverage and I'm doing that for node coverage, then whatever bug was found over here should also be found over there too. And yes, that is true. However, there is a difference between coverage in the sense that we're trying to satisfy that coverage and we're trying to find the minimum number of test cases. And this is what we usually go for. We're looking for the minimum number of test cases and just being able to create a test case. In other words, there is nothing that would stop me at the node coverage to create a test case that says, let's go like this, 1, 2, 1, 2, 1, 2, right? مش عيب ولا حرام, correct? Nobody can say I can't actually have a test case. And does this test case satisfy node coverage? Oh, absolutely, it does satisfy node coverage. Now, this particular test case that I've created to satisfy node coverage is actually stronger than the test case that I've created to satisfy edge coverage, because I've went through the loop a third time. Okay, as you can see, I'm going through the loop that third time. And it just might be that the bug is actually at that third loop. All right. So the summary of what I'm trying to say is, the higher the coverage, it will subsume the test requirements of the smaller ones. Okay, so the test requirements here is always going to subsume the test requirements in the smaller coverage. Okay, because the test requirements is talking about the minimum. However, a particular test case that I've created for the smaller coverage might actually expose a bug that is not exposed by the test case that I've created to satisfy the higher coverage. And in other words, what I'm also trying to say is, it might have been the test case that I've created for edge coverage didn't expose a bug, whereas the test case that I've created for the smaller coverage exposed that bug. Is this point clear, so that everybody understands the difference between the terminology, a test case, a test requirements? Okay, because there's a difference between them. Okay, test cases are not test requirements, and test requirements are not test cases. Okay, when I say give me test requirements, I'm asking for the minimum. Okay, when I say test cases, okay, I'm logically looking for the minimum number of test cases to reduce my effort, but there's nothing that would stop me from doing more. Okay, and that doing more part is what could expose something that the test cases for the bigger coverage or the stronger coverage hasn't hasn't exposed. Now, is everybody clear on me with this one? This is a very, very important concept. Okay, just write down in the chat something. I need to see replies on the chat, because there's nobody in the classroom to. Okay, so Abdul Nasser, Faye, is this clear, Faye?
Yes, it's clear, doctor.
Okay. Faye, صوتك اتغير قوي Faye.
لا هو فريق.
I'm just kidding. It's a joke. It's a joke. All right. Yeah. Banan, Dreya. Okay, just when I ask something, reply on text, please. Okay, just make sure that the text is okay. Good. Andrea too, on track. So let's go back again to yeah, this one over here. Okay, so we're back to this slide. Okay. So when we started to do complete path coverage, the issue that I had with this graph is that there's a loop, and means that loop I can end up creating test cases that just go on forever. And this gives rise to the concept of something called a simple path. Very, very important, okay? Now, I need you to pay very close attention to what I'm just about to say now, okay? So a simple path is a type of path, okay? So path is kind of like the most generic thing, but a simple path is the path from node, a start node to an end node, not necessarily the initial node of the graph, just any node to an end node, again, not necessarily the final node, but it's a path in which no node appears more than once. Okay, so if I have a node called number 3, I should not see number 3 more than once in that path. And again, this is the point to avoid loops, because if I'm seeing number 3 showing up over and over and over again, that probably means I'm doing loops. The only exception is if that node that I'm seeing twice happens to be the first and the last node. Now, before we get to this one, okay, so I want to go through a number of examples and you tell me if this is a simple path or not, okay? 1, 2, is that a simple path?
Yes.
All right, 1, 2, 3, simple path?
Yes.
Okay, 1, 2, 3, 2.
No.
Okay, and why not?
We visited 2 twice.
We already visited 2 twice. Yes, good. All right, 1, 2, 3, 1.
Yes.
Yes. Okay.
Simple path.
Because 1, although it's appearing twice, it's the first and the last. 5. 1, 2, 3, 1, 4.
No.
Yes.
No. All right. Because although 1 has appeared twice, it's not the first and the last. Okay. So this is the only exception where the same node can show up twice, is that if it has to be. So basically what this is saying, okay, is that if I have a node 1 over here, yeah, I can go ahead, do a big loop, and I come back. But once I close the loop, that's it. I'm not going to go any further. And this is the idea to get around, to some extent, the idea of having loops in my graph, because if I try to do complete path coverage, when I have a loop in my graph, then then I'm going to end up creating infinite number of test cases. All right. Now, so we understood the concept of a path. Now we need to understand the concept of a prime path. Now, a prime path is kind of like the biggest simple paths, okay, with an S at the end, that cannot be subsumed by another simple path. Type. What does this mean? We said 1, 2, 3. Is that a simple path? Guys, speak up.
Yes.
Okay. And not just Abdurrahman, I need others to speak up as well. Okay. So 1, 2, 3, we said is a simple path. Okay. 1, 2, 3, 4. Is that a simple path?
Yes.
Yes, it is a simple path. Okay, it's had it. No node appeared twice, so we don't even need to bother with the whole checking of the first and the last node. Type. Now, both of them are considered simple. Okay, but the bottom one is considered a prime path, whereas the top one is not considered. It's not considered a prime path because the entire subpath over here, and the entire simple path of the first one is completely subsumed by the prime path in the the simple path of the second path. Okay. So when it comes to prime paths, the second one is considered a prime path, whereas the first one is not. Okay. What if later on I found out there's a path that goes 1, 2, 3, 4, 5, then that second one is no longer a prime path, and then that last one becomes a prime path. Of course, if it is a prime path, it's also a simple path. So again, we have the generic notion of a path, and then if it's a path, it could be a simple path, and if it's a simple path, it could be a prime path. So a prime path has to be a simple path, and a simple path is always a path, but not necessarily the opposite. All right. Now, the whole point, what we're looking for prime path is that, yes, I don't really care about those first two, because if I do create a test case that goes through the entire prime path that we see at the bottom, 1, 2, 3, 4, 5, that means it's going to go through the one before, which is 1, 2, 3, 4, and the one before that, which is 1, 2, 3. So we honestly don't really care that much about this one or that one, because if I do a test case that covers this one, it's going to cover the first two. Okay, is this clear for everyone?
Can we have multiple prime paths?
Yes, we can have. So a little later on, it's an excellent question, Abdurrahman. A little later on, I have a path that goes, that says 7, 8, 9. Okay, type, is 7, 8, 9 subsumed by the one at the very bottom? No. Okay, 1, 2, 3, 4, 5 got nothing to do with 7, 8, 9. So then this one becomes a prime path as well. What if I have another path that says 0, 1, 2 for some reason? Okay, yes, I see the 1, 2 subsumed over here, but not the entire path. So again, this becomes a prime path. Okay, and then later on, when I start to create test cases, I'm going to look for test cases that cover the prime paths only, not simple paths that has been covered by bigger prime paths. Okay?
Yes.
Doctor,
Yes.
just asking. So, for example, the first two that you put 1, 2, 3, and 1, 2, 3, 4. Will they both be prime paths, or only one of them?
No. If I had 1, 2, 3, and I didn't have 1, 2, 3, 4, then 1, 2, 3 would have been a prime path. But as soon as we get 1, 2, 3, 4, and I see that 1, 2, 3 could be wholly consumed by 1, 2, 3, 4, then 1, 2, 3 no longer becomes a prime path. A little later on, we ended up with 1, 2, 3, 4, 5, which طبعا fully contains 1, 2, 3, 4. So 1, 2, 3, 4 then no longer becomes a prime path. And we look at 1, 2, 3, 4, 5. And again, the concept is, if I'm going to create a test case to cover 1, 2, 3, 4, 5, then logically that also means I'm covered 1, 2, 3, 4, and that also logically means I've also covered 1, 2, 3. Now, 7, 8, 9, the test case that I've covered 1, 2, 3, 4, 5 doesn't cover 7, 8, 9. Okay, so I need another test case. All right, and I would say I have two prime paths. Okay. A little later on, I created 0, 1, 2. Type 0, 1, 2, well, a part of it is part of the 1, 2, 3, 4, 5, but it's not the whole thing. And because it's not the whole thing, it still remains as a prime path. Okay, so just to clear this, all right. So if I have a simple path, all right, it's considered also a prime path until I get a bigger simple path that contains the entire smaller simple path. Then the smaller one is no longer prime, and it's just the bigger one that is the prime. Is this clear for everyone?
Yes, doctor.
Okay, very good. Right. All right. So in this example over here, I have so many simple paths, as you can see, 0, 1, 3, 0, 0, 2, 3, 0, and so on. All right. And what I'm going to be looking for to create prime paths is I'm going to look for the ones that are not subsumed by other ones. Now, when I'm looking at subsumed here, let's look at it from the bottom up. Okay, so I start off with number 3. Is it subsumed by something else? I already see something over here. So 3 is no longer a prime path. Type 2, it's already here. So no longer. 1, no longer. 0, no longer. Type 3, 0. Can I find it somewhere else? Yeah, I can find it over here. So this is no longer. 2, 3. Can I find it somewhere else? Can I find it somewhere else?
Yes.
Okay, good.
Yes.
1, 3. So I can find it here. 1, 3. It's already,
Yes.
so this one already has 0, 2. Yes. 0, 1. Yes. 3, 0, 2. Now we're getting to 3. So the bigger the what's it called? The path becomes, the simple path becomes, the more likely it is this is going to end up being a prime path. Okay, so 3, 0, 2. Can I find it somewhere else?
Yes.
Yes, so no. So 3, 0, 1. Stop 3, 0, 1. Can I find it? Yeah, here it is. Then no. 2, 3, 0.
Yes.
Yes, I can find it here. 1, 3, 0. Yeah, it's right over there. All right, so 1, 3, 0 because it's right over in this one. And again, you can see I started off with a smaller simple path, and then I found out as a bigger one, so I crossed out that smaller one as a prime, and then even the bigger one, I found out a bigger simple path to make this one not a prime path anymore. Okay, type 0, 2, 3. Yes, I find it over here. 0, 1, 3, I find it over there. 2, 3, 0, 1. Can I find that in a bigger path? Guys? Okay, so 2, 3, 0, 1 becomes a prime path. And as you can see, it is one of the ones at the bottom. Matter of fact, each one of the ones above over here, all right, is becoming a prime path. Okay, now, something to note as well. You look at something like this path and this path over here, and you say, oh, Allah, it's the same numbers. Yes, but it's not in the same order. Makes a difference. It has to be within the same order. Okay, so 1, 2 is different than 2, 1. Okay, 1, 2 means I'm covering this edge. 2, 1 means I'm covering that edge. Completely different path. So don't just look at the numbers and say, oh, Allah, all 4 numbers here, I can find them in all 4 numbers here. Yeah, but the order is different. And if the order is different, that means it's a different path. It has to be at the same exact order. So if it was 1, 2, 3, and the other one was 1, 2, 3, 4, then 1, 2, 3, 4 subsumes 1, 2, 3. Type. If I had 1, 2, 3, and then I had 1, 2, 4, 3, no, it doesn't subsume. Okay, because 1, 2, 4, 3 has a different order than 1, 2, 3. That's a path. That's a completely different path then. Okay? Is this clear for everyone before I move on?
Yes.
All right. Type. So we saw this graph before, and we said that if we're trying to do complete path coverage on this graph, it's not going to be feasible. It's not going to be feasible because we have a loop. Right, and we're going to go on forever. Now that we're going to do the exercise again, we're going to do it trying to do prime path coverage. Now, it's hard to eyeball prime path coverage. All right, just like we were doing in edge coverage and node coverage. Okay, even if you remember last lecture when we were doing edge pair coverage, so 2 edges, even that was a little bit tricky. But if you remember when we were doing edge pair coverage, I told you to begin at a certain number and then trying to go up. We're going to do the same thing over here, but we're going to do it in a structured manner, just like we did. So the first thing I want to do is, I'm going to look at length 0. Okay, paths that have length 0, which means I'm actually looking for node coverage. Okay, so length 0, I got 0, 1, 2, 3, 4, 5, and 6. Okay, and I usually put a little exclamation mark to say that 6 is a terminal node. Okay, just for my own information. Okay, now what we're doing, we started off with something simple. Now we're going to look for something bigger, okay? But the first one that has 0 edges. Next one, we're gonna look for 1 edge, and then next level is gonna be 2 edges, and so on. And we'll see which ones subsume the bigger one, okay? Type. Length 1, can somebody help me? Length 1. Length 1 actually means edge coverage. Can somebody tell me what are the test requirements?
0, 1.
0, 1. We did this before, by the way, because it's the same graph. 0, 1.
0, 2.
0, 2. Yes.
1, 2.
I want you to say 1, 2 at this point because we need to finish the zeros first. So 0, 1, 0, 2, and then
1, 2.
1, 2,
2, 3.
2, 3,
2, 4.
2, 4,
4, 5.
4, 5,
4, 6.
4, 6. Now, at this,
5, 4.
did we do something? Yeah, 5, 4. 5, 4, yes. Good job. Okay. Now, at this point, I'm going to look at all the test requirements that I had from the previous step, and I see which ones were covered. 0, is it covered? Yes. 1, is it covered? Yes. 2, is it covered? Yes. 3, 4, 5. Matter of fact, everything is covered. Okay. And this one denotes an end node. Okay. So we don't have anything left from node 0, from length 0. Now let's do length 2. Okay. Now that's actually edge pair coverage, if you think about it. Type. What are the test requirements?
0, 1, 2.
Okay. 0, 1, 2.
0, 2, 3.
0, 2, 3.
0, 2, 4.
0, 2, 4.
0, 1, 2, 3.
And 1, 2, 3.
1, 2, 4.
1, 2, 4.
2, 3.
Okay, stop, so that's enough. Okay, I need somebody else to be involved. Thank you, Abdurrahman. Now, Banan, if you don't want to speak, you can just type. Okay, and I'll just say it out loud on your behalf. So we're starting off from the 2. Okay, Banan. Yeah, 2, 4, 5. Yes, now I saw it. Sorry. 2, 4, 5. 2, 4, 6. 2, 4, 6. Next. Keep going, Banan. So if the 2s are finished, let's do the 3s. There's nothing for the 3s, صح? Okay. Oh, there's still 2, 3, 6. Now 2, 3, 6. So let's do it this way because we always want to do the structure. Always look for the smaller number first. Yeah, Banan. Okay, and for the rest of you. So we did 2, 3, 6, 2, 4, 5, and 2, 4, 6. Now, in an exam, if you go 2, 4 before you go to 2, 3, you might end up missing 2, 3, 6, and it ruins the entire exercise. Okay, so 2, 3, 6, 2, 4, 5, 2, 4, 6. What else? So number 3, can we have something from number 3? Okay, type. Number 4, do we have something from number 4? No, we do.
4, 5, 4.
We got 4, 5, 4. Okay, so I see Faye. Faye, can you, is there anything else from the 4? No? But is there anything from Faye from the 5? 5, 4, 6. But before we do 5, 4, 6, there's a different number that we need to look for first. So I'm gonna put down 5, 4, 6 because 5, 4, 6 is okay. Yes, 5, 4, 5. Always look for the smaller numbers first. Okay. Now, Faye, tell me, 0, 1, is it consumed by something in L2? Okay, I'm looking here. I'm looking at this side of the screen. Okay, it's time to cross out the numbers. Okay, so 0, 1 is subsumed. 0, 2. 0, 2. Okay, so it's not shown on the chat for some reason. Yes. 1, 2. Yes. 2, 3. Yes. 2, 4. Yes. 4, 5. Yep. 4, 6. Yes. 5, 4. Yes. So the entire length 1 is subsumed in length 2. So next up, we'll pick it up a little bit more. Length 3. Okay. That's 3 pair coverage. طيب. يلا. Faye, can you just keep on going? So let's start off with zeros. Okay, 0. Now 3 pair means I'm looking for 3 commas. Okay, 3 commas this time. 0, 1, 2, 3. Okay. If you guys see Faye slipped on something, just let me know. 0, 1, 2, 3. وبعدين 0, 1, 2, 4. Good. Next. Let me just close this over here. 0, 1, 2, 4. After 0, 1, 2, 4. Are we done with the zeros? No. We got 0, 0, 2, 4, 5. Next. And we missed one, huh? I missed one. 0, okay. 0, 2, 3, 6. Faye is saying 0, 2, 4, 5. And then 0, 2, 4, 6. And then what else? It's a lot that's starting from zeros, huh? So we got 5. We got 1, 2, 3, 6. Next. And guys, I need you to check. Okay. 1, 2.
1, 2, 4, 5.
1, 2, 4, 5. Okay. Because I'm busy writing down, so I can't really check everything as we go. Next.
1, 2, 4, 6.
1, 2, 4, 6. Next. 1, 2, 4, 6. بعدين. It's gonna get easier now that the numbers get higher because you start to reach the end of the graph. Once you reach the end of the graph, it becomes more difficult to find. Okay, so we got so Faye said 2, 4, 5, 4. Common mistake. All right, and I apologize. I don't mean to call you out like that, but why is this not a prime path? Not even a simple path. And Faye, it's because 4 is appearing twice, and it doesn't satisfy the exception of being the first and the last. So 2, 4, 5, 4 is not. Okay, we don't force the issue. Okay, type. We reach 1, 2, 4, 6. What can we do with the twos? 2, 4, 5, 4. So we said we can't do that. So خلاص, I think 2 is done. 3 is done. 4 is done. 5 is done, and 6 is done. Okay. So 3 pair. I think we got 1, 2, 3. You got 8 in total. And yes, we do have the 8. Type. Banan, it's your turn now. Okay, so Banan, we're gonna be looking at this, and I need you to tell me what's in here that is already subsumed over there. 0, 1, 2, is it subsumed? Yes. 0, 2, 3. Yes. 0, 2, 4. Yes. 1, 2, 3. 1, 2, 4. 2, 3, 6. 2, 4, 5. 2, 4, 6. 4, 5, 4. No, that's good. Now, one thing you'll notice is that this is a loop. And by default, if I'm starting at a node, I'm going to loop. There's no way something can come in before, something can come in after, because automatically that means it's no longer a simple path. So once I see a loop in the list of paths that I've created, I automatically know this is going to be a prime path. Okay, 5, 4, 5.
Yes.
No. 5, 4, 5, 4, 5 is a no. Okay, it's not subsumed. I think you meant yes, as in it's a prime path, صح?
Yes.
Yeah,
It's a
okay.
prime path.
Yeah, 5, 4, 6. Okay, no. So, all right.
Prime.
So I have those three. Now, I'm going to erase all of those over there. All right. Because the point is, I'm just going to erase this first. Once I have something identified as a prime path at a certain length, and it's not subsumed by length 3, I automatically know it's not going to be subsumed by length 4, length 5, length خلاص. Once it's been identified that is not covered by a higher length than the one very next up, then automatically it's a prime path. So I'm going to put down the list of prime paths here that we've identified so far. We got 4, 5, 4, which is a loop, 5, 4, 5, which is another loop, and we got 5, 4, 6. All right. So let me erase all of this. And now we'll do length 4. So length 4 means 4 edges, means I need to see 4 commas. Yalla banan. 0. 0, 1. Okay. No, no, see 0, 1, 2, 3, yeah, banan, that's length 3. Okay. As a matter of fact, we already did that over here. Okay. So, okay, sorry, right. So that's the issue with typing, is that sometimes you can make a typo. Okay, type. Marin. So we need 4 commas. Length 4 means 4 commas. All right. Is there like nothing for length 4?
0, 1, 2, 4, 5.
1,
0, 1, 2, 4, 6.
4, 5. Yeah, it's gotta be then 0, 1, 2, 3, 6. Now, before we just jump on, okay, 0, 1, 2, 3 طبعا خلاص, 4, 5 we said that. Then we look at the 0, 1, 2, 3, 6. Yeah, that's 4 edges. Okay. How about 0, 1, 2, 4, 6? 4, 6. That's another edge. Yeah, 4 edges. Next. So I think we're done with the ones, صح? If I'm not mistaken. 0, 1, yes, Fahd, yes, 0, 1, 3, 6 is a good one, yeah. 0, 1, 2, 3, 6, yeah, yeah. And then I got 0, 1, 2, 4, 6. And I think that's really the end of it when it comes to length 4. Can anybody spot anything from the zeros? How about from the ones? Anything length 4 from 1? No. Okay. So let me just do a quick check. Yeah, so there were just 3. All right. Type. Now, who was it? Dereya, are you here? Ibrahim Suelam, are you here? Ibrahim? Oh, I guess he's not in. Okay, Abdurrahman, back to you here.
Yes.
Abdurrahman, we're gonna look. Oh, no, that's not what I wanted to do. How do I undo? I don't know how to do like erase that thing that I just done a moment ago. Oh, alhamdulillah. I thought I gave it a try and it worked. Okay, so Abdurrahman, we're going to be looking at this list over here. And we're going to see from this how many of it can subsume entire paths in here. So 0, 1, 2, 3, is it subsumed completely?
Yes.
0, 1, 2, 4?
Yes.
0, 2, 3, 6?
No.
No. Okay, so we want that. 0, 2, 4, 5?
No.
0, 2, sorry, you said no. So 0, 2, 4, 5, you said no, so it's another prime path. Type 0, 2, 4, 6.
Prime.
Okay, good. 1, 2, 3, 6.
It's also a prime.
No. 1, 2, 3, 6 is here.
No.
Okay. 1, 2, 4, 5. Not prime.
Not a prime.
Yeah. 1, 2, 4, 6.
Not a prime.
Not a prime. Okay. طيب احنا هناخد بقى دولت. All right. And then we'll add them to the list of prime paths. So we got 0, 2, 3, 6, 0, 2, 4, 5. And then finally, 0, 2, 4, 6. The طبعا plus the ones that we had at the top. Okay. So let's erase this. Okay. Next up, we said length 4, length 5. Do we have anything at length 5? Anybody this time?
No.
Okay, I don't think there is. Let me just check again. Yeah, so length 5, I don't have it. And now when I see this situation, خلاص, I stop the exercise and I look, all right, then I've got obviously everything that I've identified in length 4, that becomes prime paths, plus those that I had at length 3, plus those that I had at length 4, okay? So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, a total of 9 prime paths, okay? All right, so as you can see here, the prime path, I got 3 over here, 3 over there, and 3 over here. All right, is this clear for everyone? Yes.
So when we create the test requirement, we only have 9 elements.
9 elements? Yes, yes. Now, exactly. So when I'm creating, let me just erase the screen so that okay. So here are my prime paths. Okay. In other words, what I'm focusing on are those 9. These are my 9 test requirements that I really care about, because everything else is subsumed by something else. صح? All right. So I'm gonna create a test case that runs through 0236, another one that runs through 0246, and I know it's probably I'm probably gonna need 9 test cases. Okay. Maybe this one and the loop, I could have satisfied it by 1 test case. So it's not necessarily has to be 9. It could be less. Okay. Because whatever loop that takes me through inside over here, 454 or 545, is going to probably be the same test case anyways. Okay. Now, if it's 454 only, I would have just come inside once and I would have left. But because I have 545, I have to come in from the outside, connect with the 545, and once I reach back to the 5 again, I have to go back out. Yeah, probably then that still means I'm gonna need to make 2 loops. All right, but if I do 2 loops, then it covers the 545 over here. Type another exercise. No, that's not what I'm looking for. Okay. Imagine, assuming I'm gonna erase this. Okay, guys, and I'm gonna replace it with a line that's going like this. Okay. What I want you to do, all right, is tell me what are the prime paths that exist in that graph that I've just drawn over here. All right. Okay. Now, let me just think about this first. Okay, so length 0, again, 0, 1, 2, 3, 4, 5, 6. Length 1. Can somebody tell me? 0, 1, 0, 2. Okay, 2, 3. No, sorry.
1,
0, 1, 0, 2. 1, 2. See, even I slip up sometimes. Okay, then we got 2, 3, 2, 4, 3, 6, 4, 5, 5, 4. No, actually 4, 5, 4. There's actually 4, 6. And then finally, we got, was it 5, 4? Okay, meaning that everything over here is already subsumed.
5, 2, doctor.
Oh, yeah, 5, 2. I'm looking at still the old graph, but that 5, 2. Yeah, 5, 4. Okay, length 2. No, I don't know why
Doctor, didn't we erase that arrow?
yeah. Oh, yes. I'm still trying to see visually. I'm still seeing the old arrow for some reason. So we got the 5, 2, yes. So length 2. Now, what I want you to do is do it on your own now, and then in a couple of minutes, I'm going to ask you how many did you create, and I want you to write it down on the chat. How many did you actually find? Length 2. Any takers? How many did you come up with? No, I'm not writing on paper, so I'm just doing it by hand. I hope I didn't mess up, but let's see what your answer is. Benan, Ibrahim, Raya, Abdurrahman, hey.
Doctor, C2 is the one that has 3 numbers, right?
L2, it's not C2, it's actually, my handwriting is very bad, but that's actually length.
L2.
So yeah, the easiest way, Saadun, to remove any confusion is the number that you see, you count the same number of commas, okay? So length 1, 1 comma, length 2, 2 commas, length 3, 3 commas, okay. So Fad, I think there's more than 7. I think there's gonna be more than 7.
There's 11, Doctor, what I got.
I got 11 too. Okay, so Saadun, can you tell me the 11 that you got?
Sure.
Repeat, please, huh?
0, 1, 2,
0, 1, 2,
0, 2, 3,
0, 1, 2, 0, 2, 3, yes.
0, 2, 4,
Yep.
1, 2, 3,
Okay.
1, 2, 4,
Okay.
2, 3, 6,
Okay.
2, 4, 5,
Good.
2, 4, 6,
Mm-hmm.
and then assuming 5 can't go back, right?
It's not going back to 5. Now, let's just do 4 first.
Okay, so
I know we can't do 3 because 3 is خلاص stuck, but 4.
both 3 and 4 are stuck if you can't
No,
go 5.
no, 4 is not stuck.
452.
4, 5, 2. Okay. Remember, I did a small change in the exercise, huh? So this no longer exists.
I missed the second arrow.
Okay. And then there's a second area. So 4, 5, 2. وبعدين
5, 2, 4.
5, 2, 4. لا, before 5 to 4.
5, 2, 3.
5, 2, 3.
And 5, 2, 4.
5 to 4. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11. So 0, 1, 2 is here, 0, 2, 1, 2, 2, 3, 2, 4, 2, 4 موجودة, yes, 3, 6, 4, 5, 4, 6, and 5, 2. So all of the length 2 is there. Right. Next up, length 3. Again, I want you to do it on your own first, and then write down, okay, Banan and Faye, I didn't get anything from you. Okay, so length 3. I need to see how many did you get? think somebody's leaving their mic on. If you don't mind, your mic unmuted when you need to speak. Okay, length 3. Any takers? Really, is it that difficult? Okay, so we got 8. 5. Faye, can you tell me what are the 8 that you got? Oh, yes, all right, so we got, she said we got 0, 1, 2, 3, 0, 1, 2, 4. And again, I have to say, I can't be writing and checking all at the same time. So I'm gonna have to assume that yours is correct. And somebody who has the mic on, if you don't mind, I think that person is not even on the desk. I think I can actually use them. There we go. 1, 2, 3, 6, 1, 2, 4, 5, 1, 2, 4, 6. Okay. So you said you got 8. I have to check the
There are more.
There are more? Okay, can you tell me what's more? I would think there's more, yeah, because we didn't even look at twos. We got 2, 4, 5, 2. And I didn't see the new red line. Huh?
4, 5, 2, 3.
I don't know what is it about the new red line was. خلاص كده that's it with the twos, huh? 2, 4, 5, 2. طبعا, okay, that's it. You can't go back. And then next up, the threes is you're stuck. 4, you got 4, 5, 4, 5.
2, 3.
Before we do 4, 5, 2, 4, we want to do 4, 5, 2, 3. Okay, remember 4, 5, 2, 4, and I can already tell that this is a loop. Okay. But then, what else do we have? From the 5, how far can we go?
5, 2, 3, 6.
5, 2. That's length 3, yeah. 5, 2, 3, 6.
5, 2, 4, 6.
5,
5, 2, 4, 5 first.
5, 2, 4, 5. So there's a lot. 5, 2,
4, 6.
6. طيب. Let's look at length 2. Is 0, 1, 2 here? Yes.
Yes.
0, 2, 3. Yep.
Yes.
0, 2, 4. Yeah. 1, 2, 3. Yes. 1, 2, 4. Yes. 2, 3, 6. Is it here? Yes. 2, 4, 5. Yep. 2, 4, 6. Yep. 4, 5, 2. I can see it. 5, 2, 3. I can see it. 5, 2, 4. So an entire length 2 is there. Let me just erase all of this. And again, I already know once we do length 4 that 4, 5, 2, 4 is going to be a prime path. Type length 4, beginning with 0. I'm going to give you a moment to do it on your own before I jump in. Abdurrahman, can you mute the sound? Yalla Sadoun, how much did you get for length 4? We're still working on it. Fahd.
Still working on it, doctor.
Okay. So your quiz on Monday, second quiz will contain a question exactly like this one. So you already know what the question is. You just need to know what the graph that I'm going to bring you with. That's the only thing that differs. Once you reach the higher numbers like length 4 and length 5, you'll see that the numbers tend to start off from the zeros. It's trickier, but then as you get down to the bigger numbers like 3 and 4 and 5, you know, it becomes easier because there isn't enough room. So I can already see.
Doctor, can we look more than one time?
Can
Or
we,
it's just
can we what?
if you go 5, then 2. When you reach 5 again, you just stop, right?
So if you go 5, 2, 4, 5, which is this one over here, I didn't
Yeah.
notice. That's a loop.
But you can't go 2 again. That's what I mean.
لا خلاص. Okay, because if you have 5, 2, 4, 5, followed by another 2, why is it doing this? Then the numbers 2 is showing up twice and it's not the first and the last, and also it's violating for a second time because number 5 is showing up twice and it's not the first and the last.
Then I'm done, doctor. It's 11.
11?
Yes.
MashaAllah.
I think so.
So yalla, let's have it. 0, 1.
Mistake.
Doctor, I got only 3.
Man, عشان كده I'm surprised that length 4 is 11th يعني. Okay, let's see. Let's see. That's the whole point of the exercise. 0, 1.
Never mind. There are 2 mistakes. I already found them.
خلاص.
0, 1, 2, 3,
Abdul
6.
Rahman. Okay, you can go ahead then. Well, Sadoun, you fixed the mistakes. So I got
0, 1, 2, 3, 6.
1, 2, 3, 6.
0, 1, 2, 4, 5.
You know, I'm just gonna do. I'll tell you what. No, I don't want to discard this. Oh no. Oh my! I ruined it. I was getting annoyed by the graphics. But anyway. You still have the exercise in front of you?
Yes.
Okay. Because I've done something silly. Okay. Now, صراحة, I can't see the graph. Okay. So now you gotta tell me the numbers and I'll just have to write it down myself. Okay. He said 0, 1, 2,
0, 1, 2, 3, 6.
0, 1, 2, 3, 6. I'll try to remember as much as I can. And then you got 0, 1.
2, 4, 5.
0, 1, 2, 2, 1, 4, 5, yeah. Okay. Then is there
0, 1, 4,
Okay.
6. 0, 1, 2, 4, 6.
2, 4, 6.
That's all I got.
From the ones, is there 'cause
Yes, doctor. There's one more.
from starting 1, is there anything that is 4 edged?
No.
Okay. Now what I want you to do, all
There
right?
is one more.
There's one more. Okay.
45236.
Okay, 452. That's a good job, Banan. Excellent job. Okay. So it gets tricky. You have to check every number. Yeah, yani, you don't just go to number one and say, ah, طالما number one there's nothing and خلاص, then the rest is nothing. You go to number two, you go to number three. Okay, so 45236. Okay, now unfortunately I have actually erased the length 3. I think we had 11. Now what you need to do, we have to wrap up the lecture anyways. You look at this, okay, and then you look at the ones from the length 3 and see which one you cross out. I know there were 2 loops, okay, one starting from 4 and one starting from 5. So those 2 loops are automatically prime paths, okay. And then next up we do, was it length 5? All right, and then basically it's more of the same, more of the same. And once you get to length 5, you probably see a lot less numbers, a lot less paths. And then length 6, probably there's no length 6 to begin with, okay. And then the ones that are left become your prime path. All right, now I'm gonna stop here. Any questions about what I was covering today's lecture? Guys, any questions? All
No,
good?
thank you.
All right, so you're gonna get a question exactly like this on Monday. So don't tell me, you can't say I didn't tell you. Obviously, the graph is
Doctor,
different. Same idea, but the graph is gonna be different. And you're gonna get a question about faults and errors and what's to call it, the last one? Faults, errors, and failure.
failure.
Now, before I leave you, I want to ask you about the midterm. All right. Now, we're actually ready. With today's lecture, we finished the material that's going to be covered in the midterm. Okay. We're not going to be covering any more material for the midterm. Okay. Today is October 30th. And today is a Wednesday. And we got classes on Monday. So the next class on not October 30th, sorry, September 30th. A little bit ahead of schedule here. Okay, so next lecture is what? What day on the week afterwards? This is week 5.
5 October.
October 5th, yeah. And then the one after that is October 7th. Okay. So is October 7th, does anybody have any conflicts with October 7th?
Yes, we have a midterm.
I'm just saying that I just want to let you know that, right after you do the quiz over here, there's no more studying for this one. I mean, it's up to you. Okay. Let's look at week 7. Next lecture is October 12th. Any conflict? Any conflicts on October 12th?
If it is on Wednesday, it will be better, but I'm fine with Monday.
Well, we need to, I mean, we're finishing the material here today, okay? So that's already 10 days. I don't want to expand any much, because I'm going to be teaching new material here, okay? I don't want to be teaching a whole lot of new material and your brain and your mind is still with the exam, okay? Yes, we're avoiding October 5th, yeah. So I think October 12th is good. Yeah, I agree too. So we'll set it up as October 12th. I'll try to book the rooms. All right. And yeah, I think it's good. Now, do you want to have the, well, actually, I don't think it should be an issue. No, never mind. Okay, so that's it for today. I'll see you inshallah on Monday, and be prepared. There's going to be a quiz on that day, 2 quizzes. All right. So attendance is mandatory. Okay. I'll see you then. Oh, Saadun, you had a question?
Yes, 2 quizzes.
Yes. Basically, 2 questions. The first quiz is about errors, failures, and what's the last one? Faults. And the second question is going to be prime path analysis. Prime path coverage, I mean.
And also, doctor, I just wanted to ask for October 12th, it won't be in the same class time?
It will be the same class time, yes.
So why do you need to book the room? Isn't it the same
I
room?
don't need to book a room. Oh, I said to book. No, I meant to book the proctors. But actually,
Okay.
we're only 8. I don't think we actually need proctors to begin with. No, never mind. So October 12th, I'll do the exam myself. No need for proctors. My other class I do need because I have girls upstairs. Never mind. Okay. Any questions, guys, before I sign off?
Thank you very much, doctor.
Thank you, guys. Thank you. We'll see you later. Huh?
Yes, Doctor, one final question.
Go ahead.
يعني the two quizzes will be